A vehicle cooling system removes excess heat from the engine. The system transfers heat from the engine into the vehicle interior or the atmosphere using heat exchangers called radiators. To perform its job, the cooling system must cool the engine enough to prevent damage, while keeping the engine warm enough for efficient operation. In addition, the cooling system must work in all operating conditions, adjusting to changes in engine load, vehicle speed, and outside temperatures. Finally, the cooling system must contain increased pressures created by engine heat. The cooling system must carry heat from inside the engine to the atmosphere. The system uses a liquid called coolant to accomplish this. While our coolant contains some water, pure water makes a very poor coolant. Pure water allows damaging corrosion inside the cooling system, boils at a relatively low temperature, freezes easily, and has poor lubricating properties. To solve these problems, chemicals are mixed with water to provide the needed properties. Honda or Acura coolant prevents corrosion, lubricates the water pump seal, increases the boiling point, and lowers the freezing point. Coolant can only transfer heat efficiently when liquid. If coolant boils into a vapor, cooling efficiency drops dramatically. Because of this, the cooling system operates under higher pressure to increase coolant's boiling point, maintaining cooling efficiency. Because the cooling system contains heat and pressure, do not remove the radiator cap when the cooling system is hot. Removing the cap releases system pressure. At a lower pressure, the superheated coolant flashes immediately to steam, scalding anyone in the vicinity. In addition, coolant can be a toxic substance if ingested in large enough amounts. This article from Service News provides more information. Water pump uses an engine-driven impeller to draw water from the radiator and pump it into the engine water jacket. This pump may be driven by an accessory drive belt or by the camshaft timing belt. The pump includes a shaft seal between the impeller and the shaft bearings. During normal operation, this seal may allow small amounts of coolant to leak past, which can drip out of passages in the water pump housing called weep holes. This hole may normally contain a few drops, but if the pump seal fails, a steady stream of coolant flows out. Inside the engine, the water pump sends coolant into the space between the cylinder walls and engine block called the water jacket. As the coolant moves through the engine, heat from combustion transfers into the coolant, reducing combustion chamber temperature. The head gasket includes passages for coolant to flow from the water jacket into the head passages. The water jacket may also include a cooling separator to direct coolant in a specific direction. If you fail to install the cooling separator during engine work, coolant bypasses the water jacket, reducing cooling efficiency. The cooling system typically includes several additional engine-mounted components. To control temperature in the water jacket, a housing containing a thermostat controls coolant flow between the engine and the radiator. The thermostat is a temperature-controlled valve. When the engine is cool, the thermostat stays closed to prevent coolant flow. As the engine warms up, the thermostat opens to allow coolant flow and controls flow to maintain a target temperature. Additional engine-mounted components include external housings with several hose connections or bleed bolts at the high points of the water jacket. Outside the engine, the cooling system uses several different components. These include hoses, heat exchangers, expansion tank, and coolant reservoir. Coolant system hoses provide a path for the coolant and use rubber and fabric construction to help isolate engine vibration from the external components. Because of this, hoses require regular inspection for wear, leaks, and damage. The radiator and heater core both act as heat exchangers to dissipate engine heat from the coolant to the air. The radiator sends excessive heat into the outside air, while the heater core directs engine heat into the passenger compartment. The cooling system also includes an expansion space and radiator cap at the highest point. Typically, these parts are at the top of the radiator, but some vehicles use a remotely located radiator cap or include an expansion tank above the engine. Any vapor in the cooling system collects in this space. During engine operation, the cap allows pressure to build in the cooling system. This increased pressure also raises the boiling point of the coolant, reducing the likelihood of steam forming in the engine. If the cooling system exceeds a preset pressure, the radiator cap vents coolant and stores it in a coolant reservoir. The coolant remains in the reservoir until needed. If the system pressure drops below atmospheric pressure while the system cools, the cap allows coolant to return to the engine, filling any voids in the expansion space. The cooling system typically includes electric fans to increase airflow through the radiator at low vehicle speeds. The fan control circuit always starts the fan at high engine temperatures, but may operate the fan at other times. When the driver activates the air conditioner, the cooling fans run continuously. Also, be aware that high engine temperatures can cause the fans to run with the ignition turned off. During vehicle maintenance, the cooling system may require inspection or service. This includes visual checks, coolant testing, and coolant replacement. During a visual inspection, check rubber hoses for bulging, deterioration, or rot. Make sure the water pump and belt tensioner bearings run straight and true. Rotate the tensioner and water pump shaft to check for roughness and rock the flange or pulley from side to side. If you feel roughness or excessive clearance, replace the worn-out component. During inspections, check for the proper coolant mixture. Incorrect mixture strength affects the boiling and freezing points of the coolant. Also check the coolant's age. Coolant's corrosion protection and lubrication properties both decline with time. If your coolant checks identify a problem, replace the coolant with our factory pre-mixed coolant. This coolant requires no additional mixing and is engineered to meet the needs of Honda vehicles. If the vehicle is losing coolant, inspect the cooling system for leaks. As always, start with a visual inspection. There are 3 types of coolant leaks. First, hoses can leak at the connections or from holes. Second, components such as the water pump or radiator can leak from seals or seams. Finally, gaskets on the engine can leak due to age or corrosion. Check the hose ends for drops of coolant and check the underside of the hoses for leak trails. Also look for streaks of coolant in the engine bay caused by a pinhole leak in a hose. Look at the water pump, radiator, and heater core for visible leaks. Check the water pump shaft and seal by looking at the weep hole for evidence of a coolant stream. When checking the radiator and heater core, check the core for wet spots and look for coolant droplets at the joints joining the tubes with the end tanks. Finally, check for coolant leaks at the machined surfaces of the engine. These joints typically use flat gaskets, but a few components use a rubber seal. These joints typically leak once the engine warms up and are unlikely to show leakage during a visual inspection on a cold engine. When checking for leaks on these surfaces, look for stains or discoloration at the mating surfaces during your visual inspection. The head gasket may allow coolant to leak into the combustion chamber. When this occurs, the coolant vaporizes and exits out of the tailpipe, leaving no visible coolant trail. To check for this fault, remove the radiator cap and check for bubbles in the coolant with the engine running. With no pressure in the cooling system, a leaking head gasket forces combustion gases into the water jacket, and the gases appear in the radiator as small bubbles. If you find a gasket leak, be sure to inspect the gasket surfaces for corrosion damage or warpage after disassembly. If you identify a damaged gasket surface, replace the component. If you don't find the leak using a visual inspection, you can pressurize the cooling system with a pressure tester. This forces bubbles or coolant out of the coolant leak. To use the tester, start with a cold cooling system and do not start the engine. Running the engine with the tester attached will overpressurize the cooling system and lead to damage. Once you've pressurized the system, recheck all components for coolant leaks. If no leaks are visible on the outside of the engine, remove each spark plug and check for coolant inside the cylinder. Also check the radiator cap using a test adapter. Visually check the radiator cap gasket and filler neck for damage, and then check cap performance using a test adapter. A cap that doesn't meet its rated pressure can release too much coolant and lead to engine damage. When the vehicle does not leak coolant but still overheats, several components may be at fault. Check cooling fan function, confirm the thermostat opens, and test radiator performance. To check the fans on cars with an air conditioning compressor, start the engine and press the AC button or set the climate control to the lowest temperature. With the air conditioning on, the cooling fans should turn on. If the fans do not run, check for a problem with the fan circuit or fan motors. If the fans do run, the circuit is good. Turn off the air conditioning or climate control and go to the next step. When the coolant in the water jacket reaches operating temperature, the thermostat should send warm coolant to the radiator. With the engine running, connect a scan tool and check coolant temperature. When the engine temperature approaches 180 degrees, coolant flow should warm the upper radiator hose. If coolant flows, move on to the final fan check. If the engine temperature exceeds 210 degrees and there's no coolant flow, check the thermostat using the service manual procedure. If the thermostat opens normally, make sure the fans run to cool the engine. If the engine reaches 210 degrees and the fans do not run, check the fan control circuit. If the fans run but the engine temperature remains high, make sure both fans blow air toward the rear of the car. If a fan blows in the wrong direction, the fan harness is defective. To repair this problem, reverse the leads in the fan connector. If the thermostat and cooling fans are working correctly, check the radiator performance. Using an infrared thermometer, measure the temperature difference between the upper to the lower hose. There should be a minimum difference of 15 degrees Fahrenheit between the two hoses. If there's insufficient temperature change between the hoses, check the front of the radiator for blockage caused by dirt, insects, or debris. Finally, check the radiator for internal problems such as plugged tubes. When replacing the coolant, be sure to follow all service manual procedures. This helps guarantee you've drained the coolant from all portions of the cooling system. Many service manuals ask you to start by turning on the ignition and setting the temperature control to high. This opens the heater control valve to make sure coolant drains out of the heater core. On some vehicles, removing the radiator drain bolt only drains coolant from the radiator. For these vehicles, the service manual asks you to open drain plugs on the engine block, which drains coolant from the remainder of the cooling system. Finally, the manual instructs you to remove the coolant reservoir, flip it over, and drain the last of the coolant in the system. Once you've drained the coolant, prepare to refill the cooling system. Replace and tighten the drain bolts and remount the coolant reservoir. Refill the reservoir until the coolant reaches the max full line. On some vehicles, the cooling system layout prevents air from making its way to the expansion space. To solve this problem, service manuals instruct you to open bleed valves at the high points of the cooling system, which allows air to escape. When working on cars with bleed valves, open the valves before adding any coolant. Fill the cooling system until coolant reaches each bleed valve. When coolant begins to flow out the bleed valve opening, close the valve. After filling the cooling system, you may have to open the thermostat to burp or move any remaining air pockets into the expansion space. To burp the cooling system, remove the radiator cap and warm the engine up until the cooling fan turns on and off twice. Add enough coolant to fill any void in the radiator. Once the system is full, idle the engine to make sure it remains cool. Also see if the heater blows warm air. If the car fails these checks, an air bubble may be preventing coolant flow to all parts of the system. After the engine cools back down, check all the bleed valves for air. In some cases, pulling up on the upper radiator hose or lifting the front of the car may help move air bubbles into the expansion space. Once the engine cools properly, finish the job by flushing off any spilled coolant and, if needed, resetting the maintenance minder. Once you've completed these steps, you've completed the refill and the car is ready to return to service.